Okay, for geometry, lesson 8.3. I don't know why it says this, that's not right, but this is geometry lesson 8.3, and we are officially starting trigonometry today. So this lesson is over specific trig tools. They're just ratios that I really do want you to memorize, but actually I'm going to show you a little method to keep it kind of locked in your brain, a little mnemonic device. So what I want you to write down is the word Sohcahtoa. So I know you're like, wait, what? Is that a real word? No, it's not. It's a made-up word, and it is Sohcahtoa. So Sohcahtoa actually stands for sine, cosine, and tangent. And sine has a ratio of the opposite over the hypotenuse. Cosine has a ratio of adjacent over hypotenuse. And tangent has a ratio of opposite over adjacent. And that's why I said Sohcahtoa, because you can kind of remember what the ratios are if you can remember the word Sohcahtoa. So this is very commonly used in geometry, the word Sohcahtoa, referring to the trigonometry ratios. And here they are written as a little bit fancier. So my Sohcahtoa, sine actually has an E on it, but these are the abbreviations that you will see on your calculator. Yes, you'll be able to use your calculator. So here is sine, and they only put 3 on the calculator. I think that's silly because obviously they can fit more than 3 letters on there like they did up here, but this is sine, cosine, and tangent. So be sure you can find those on your calculator. You'll be using your calculator a lot with these ratios. And the sine stands for opposite over hypotenuse. So just like sine, opposite over hypotenuse. When we do cosine, it means adjacent over hypotenuse. Cosine, adjacent over hypotenuse. And then tangent, opposite over adjacent, so tangent is opposite over adjacent. So Sohcahtoa just stands for helping you remember what order of things we're talking about. Now that you've heard this, you probably still have no idea what I mean, so let's go try some of these and I will show you what I mean. So if we are trying to find the side length that's x, so the problem here is you know it's a right triangle, and normally your brain might say, oh, it's a right triangle, so I'm going to do Pythagorean theorem. But we only have one hypotenuse length. We don't have the other leg length or the other leg length, so there's no way you can find the one missing side. So you're going to have to use a degree of an angle along with the hypotenuse, and what we're looking for is the short leg. So here's how to look. Look at the degree it gives you. So it gives us this angle down here at 28 degrees. So I need to decide which of these 3 trig ratios to use to find my missing side length. And now let me explain which one is considered the adjacent and which one's considered the opposite. I hope you know which one the hypotenuse is. If we're looking at any right triangle, the hypotenuse is always the one across from the right angle. It's always the longest side. So I don't think you need retaught which one the hypotenuse is. But I want to make sure you understand the difference between adjacent and opposite. So looking at the angle, the 28 degree angle, the opposite side would be the side that it opens up to. So if you think of this as like a megaphone, like something you speak into, it'd be like where the words come out. So it would be the side that is opposite the angle. So from 28 degrees, x is our opposite. Okay, 19 is the hypotenuse, and if we had anything to do with this other one, it would be adjacent, because the word adjacent means right next to, so it touches basically the angle, and we know it's not this one, because this one, even though it touches the angle too, it is our hypotenuse. So it's the other one that is just adjacent to the angle. So what we have here is a 28 degree angle, and we have an opposite, because that's x, and we have a hypotenuse. So I'm going to go look at my ratios and see what I can use with opposite and opposite and hypotenuse. So opposite and hypotenuse, opposite and hypotenuse. No. Opposite and hypotenuse, yes. Opposite and hypotenuse, no. So we want to use the sine. So we're going to choose to use the sine function. So I want to set up an equation with sine equals opposite over hypotenuse. So sine of our degree, sine of 28 degrees. So you need to put 28 degrees here. So sine 28 equals, and that's what this little theta symbol means. You're going to put the degree. See how the degree is in the corner of the angle we're using? So that's why we put the 28 degrees here. So sine 28 equals opposite over hypotenuse. So our opposite is x, and our hypotenuse is 19. And you are just going to solve this just like you would any equation. So x is being divided by 19, so you're going to do the opposite, and you're going to multiply by 19 on both sides. They cancel over here, and over here you're going to use your calculator. So we have a sine of 28 times 19. So I'm going to push the sine button, sine, and see how it opens up a parenthesis. You'll need to put 28 in there and close your parenthesis. My parenthesis buttons are right here. So it automatically, here, let me show you again. When I push sine, it automatically opened up a parenthesis. So you don't have to open one, you just have to put 28, but you do have to close it. So I'm gonna go right here and close my parentheses. So sine 28 times 19. So times 19 equals, since these are ratios, they're all going to be really crazy decimal lengths, and I'm going to have you for today just round to the nearest tenth. So we'll call it about 8.9. So x is going to be about 8.9. And I always like you guys to check it. If this side length is 8.9, does that make sense? It should, because the longest length is the hypotenuse, and that's 19. So I think it's very reasonable that this shorter side length could be about 8.9. Okay, let's try B. So B, right away, yes, you could look at sine of 45 degrees, and we have the opposite over one of the adjacents. But here's the thing. 8.2 lesson was all about 45, 45, 90 triangles and 30, 60, 90 triangles. So I hope you remember right now, we don't even have to use a trig ratio, because what you should see is that if this is a 45, this is a 45, 90 triangle, the leg lengths are equal to each other. So if this is 8, then x also has to be 8. But I promise, if you were to work this out and use a trig ratio, you would also get 8. This one would have come out evenly. All right, let's move on to C. So this is not a 30, 60, 90 or a 45, 45, 90 triangle. So you're going to actually have to choose a trig ratio and work this out. Our angle is a 68 degree angle, and we do not have opposite. Okay, 68 opens up to something we don't know. So we're not going to look for opposite this time. What we have is that x is our hypotenuse and 18 is our adjacent. So we're looking for hypotenuse and adjacent. So let's look up here. Which one is hypotenuse and adjacent? That would be this one, hypotenuse and adjacent. So we want to use the cosine ratio. So we want to use cosine of our degree equals adjacent over hypotenuse. So cosine, I'm going to write this over to the side, cosine of 68 degrees, and that equals our adjacent, which is 18, over our hypotenuse, which is x. All right, so this one's a little bit different. Over here, the known number was on the bottom, so we could just multiply and get the answer. Unfortunately, this is a little different, so let me remind you how you would solve when our unknown is a denominator. So you would start by doing what you would think so. This is dividing by x, so you're going to multiply by x on both sides. So we have cosine of 68 times x equals 18 now. Okay, and now you're trying to solve for x, so x is being now multiplied by cosine of 68, so you're going to divide by cosine of 68 on both sides. So we're just really just moving things around, kind of rearranging so that we can solve for x. All right, so in your calculator, you are going to put 18 divided by cosine 68. So 18 divided by cosine, so click your cosine button this time, 68, close your parentheses, equals, should be about 48. Let's just call it, well, I guess you can do 48.1. So about 48 48.1. And let's see if that makes sense to our problem about 48.1. Yes, because the hypotenuse is the longest. 48.1, if our short leg is 18, seems like it's a good choice. All right, let's do just a few more. I don't need to do a whole lot of these with you because it's just over and over again using these ratios. So D has an angle of 25, so it's not a fancy angle that we know like 30, 60, 90 or 45, 45, 90. So the angle is 25, and what we know is we have an opposite of 6 and we have a hypotenuse. So we need to look for opposite and hypotenuse. So let's go up here and look for opposite and hypotenuse. That would be this one. Opposite and hypotenuse is sine. So we want to do sine of 25 degrees. I'm going to write this out over here. Sine 25 equals opposite over hypotenuse. So our opposite is 6 over our hypotenuse, which is x. Okay, so we're going to have to solve this one the same way we did the previous one. It's being divided by x, so you're going to times x, multiply by x on both sides. That would be sine 25x because we've squished them together and multiplied. And so therefore now we're going to need to divide by sine 25. Okay, and then you've got 6 divided by sine of 25. 6 divided by sine, push your sine button this time, of 25, close your parentheses, is about 14.2. So about 14.2. So our x is 14.2 about. And that's reasonable. Okay, number or letter E, right away I hope you know it's a 30, 60, 90. You should see that 60 degrees and that 90 degrees and right away know it's 30. And so we can use our special ratios, which a quick reminder of a 30, 60, 90 is your short leg is x. I'm just going to change this up. Your short leg is x, your hypotenuse is 2x, and your long leg is x root 3. So you have a couple of different choices here. You can either set 8 equal to x root 3 and solve it, and once you get x, that is, then we'd have to double it because this is the actual side we're looking for. Or you can go ahead if you want to work on a trig ratio. It doesn't matter. They'll both come out to be the same answer. So since it's a lot of work to simplify radicals, let's just do our trig ratio because that's going to work too. So let's go back to our 60 degrees and know that we're looking for hypotenuse, and what we have is adjacent. So 60 degrees, we have our adjacent. We're looking for hypotenuse. So adjacent and hypotenuse, which is right here, adjacent and hypotenuse. So we're going to use cosine. So we're going to do cosine 60 equals adjacent over hypotenuse. So that'd be 8 over x. All right, here we are again, practicing that x is on the bottom one. That's okay. We're going to get really good at that. Multiply by x on both sides. You've got cosine 60x equals 8. Divide both sides by cosine 60. 8 divided by the cosine of 60 is, oops, can't even see it. That's okay, sorry. 16, so it came out evenly. So x equals, which is really this side, sorry about that, the hypotenuse is 16. All right, for F, I would definitely use the 30, 60, 90 shortcut because look what we have. We have the hypotenuse, which is twice the short leg, actually. So it's, if this is 42, then x is 21. So go back and look at your 30, 60, 90 rules to try to remember that the hypotenuse is twice what the short leg is. So there we go. G and H don't really end up working out very good. We're going to skip those two. It's okay. But I do want to practice one more. So let's look at I. We have the angle that's 42 degrees. We have opposite is x, and adjacent is 12. So I'm looking for opposite and adjacent. Opposite and adjacent. Opposite and adjacent. Here we go. So we're going to use the tangent this time. So the tangent of our angle. So we're going to use tangent. I don't think we've used tangent yet. So this is good. Tangent of 42 opposite over adjacent. So opposite is x, over adjacent is 12. Yay, this one's a little easier. Divided by 12 means we're going to multiply by 12 on both sides. And we'll just key that into our calculator. So tangent of 42 times 12. Tangent 42 times 12 equals about 10.8. So about 10.8. Okay, last thing I want you guys to look at is turn the page. The next page is a little bit quicker. I actually am debating whether or not I should have taught you this side first, because you're not actually putting degrees in your calculator. This is just practicing the ratios, not plugging in degrees. See how we have no numbers in our triangles, no degrees of angles, except the 90. And by the way, you can never go from the 90-degree angle. Using trig ratios, you have to go from one of the two other angles that's not 90. So what you'll notice on this whole page is we don't have any angle measures. So all I want you to do, every single one of these should just be a fraction that represents our trig ratio. I'm going to write Sohcahtoa up here. So I'm going to write so like this now that you know it's a ratio like that. Ka, and then toa. Okay, so again, if we have opposite over hypotenuse, we'll choose sine. If we have adjacent over hypotenuse, we'll choose cosine. And if we have opposite over adjacent, we'll choose tangent. So, oh, and actually they'll tell us what to use. They want us to use the tangent for angle z, tangent z. So they want us to choose this angle, and they want us to use tangent, which means we're going to put the opposite over the adjacent. So we're going to put the opposite, which is 21, over the adjacent, which is 28. Now the only thing you'll have to do besides writing down this fraction is, if you can simplify it, I need you to simplify it. So these both divide evenly by 7, so you should have got 3/4 for your tangent z trig ratio. All right, let's try a few more of these, and then I'll let you try some on your own probably. So cosine of letter C, of angle C. So we're down here, cosine of angle C. So they're talking about this angle, and cosine means adjacent over hypotenuse. So I want to do the adjacent, which is 16, over the hypotenuse, which is 34, and then you will just simplify that. So I think that 16 and 34 both divide evenly by 2. So this would be 8, maybe 17ths. You might check that. All right, let's do a few more. Sine of C. So we're looking at angle C. And sine is opposite over hypotenuse. So the opposite is 28. Over the hypotenuse is 35. And then just simplify. 28/35. They both divide by 7. So it would be 4/5. Okay. I think you guys get the point. I would go ahead and try a few more. Here, I'll do one last one with you. I keep saying I'll stop. Tangent of x. So we're talking about angle x. The tangent is opposite over adjacent. So opposite is 32. Over adjacent is 24. So, and oh, I'm glad we did this one because it's improper, but I just want you to leave it improper. You can simplify and still leave it improper. So these both divide by 8. So that would be 4/3, and that is still your trig ratio. Okay, I think you guys hopefully are good. Otherwise, be sure to ask questions over these ratios.